Good afternoon.
Hello, Kurt. 1 minute.
Okay.
1 minute. Open the. Hello. 1 minute. Hello.
No problem.
Just let me check. Yeah, Kurt. Hello.
Good afternoon. How are you?
Yeah, Kurt, can you please introduce yourself, just because I will just hand over because you are online. So it is better you can give a short resume about you. I will just tell that Kurt is from US and working for many years on this project. Okay.
Okay.
So introduce yourself for 3-4 minutes about your area, your work, and then we will run the recorded presentation.
Okay.
Yeah. Arun, welcome.
Thank you.
Arun, sound.
Sunte Bachchan, I'm not able to hear.
Just see, we'll put it. Priyanka, Arun को unmute कर देना थोड़ा. अच्छा, you have to unmute yourself.
Okay. Well, I can hear you guys.
Yeah. Kurt, I can hear you very well. And still we have about 13 minutes to go. So we have enough time. Okay.
All right. Can you hear me now?
I can hear you very well, Kurt.
Okay.
Yes.
So you want me to introduce myself?
Yes.
Yes,
Okay.
I can also hear it now.
No, very
Okay.
good, very good. So
There we go.
Arun is also interested. He is now secretary of IBAAS, and he is taking a lot of responsibility from me for organizing conference. And Kurt, for your information, next conference we are organizing in city called Bhubaneswar, and we will inform you much in advance so that you can take your visa. You can come to India this time.
Okay.
So maybe early next month we will have all the details and dates and everything. It's the end of October most probably, and we will inform you exactly the circular and other details. Okay.
Okay. Good. I look forward to the visit.
Oh, very good. So where are you stationed, Kurt, exactly in US?
I am in Indianapolis, Indiana,
I
which
say
is
Indian.
about 200 miles south of Chicago.
Okay.
And about 500 miles west of New York City.
Yes, I know. I have traveled many times to Texas and also to this place, your LA. This is your Los Angeles, which state it is? Yes, California. So
Okay,
I have several times to California because my daughter was doing PhD there. So but I have not traveled to Indiana. Anyway, Kurt, so are you? Could you analyze this alumina? What I was asking you earlier. Could you, in the process, what you generate alumina? So I will not ask this question unnecessarily in the meeting. Have you ever analyzed this alumina? What you produce in between from aluminum alloys?
Okay, you want the alloy or the
Alumina,
byproduct?
alumina, which is you generate during reduction of aluminium to alumina. So alumina powder. Have you ever analyzed or not yet analyzed?
Yes, we analyzed it.
Oh, very good. Excellent. Then it will be interesting to show this alumina analysis also. Maybe I will ask this question to you, then you can show me this alumina analysis.
I don't have the analysis in front of me, but we did test.
You can keep this analysis somewhere in your laptop, And when we request you, you can show, because that will be interesting for some people. Why to go back again to the aluminum metal? If alumina is interesting and the quality is something special. What is the L23 content in your alumina?
It's the aluminum oxide that we get from the reaction is vast majority just regular aluminum oxide.
Okay,
probably 90%.
99% Al23?
No, about 90%.
No, then it is not a regular alumina. Regular alumina is 98, 99%.
Right. Regular alumina is what? 3 or 4 nines pure. This
99, 99%.
Yeah. So that's regular alumina. Our alumina has it's regular alumina. The vast majority of it, and the rest of it is the catalyst and oxides of the catalyst.
Okay. Okay, you can show us this analysis, because many people may be interested to know what quality of alumina you are getting as when you are reducing the aluminum metal, when you are oxidizing this, how much you are getting. Anyway, that question may come in between, so keep this analysis result with you. Okay. Okay, so we have another 9 minutes to start. So then we will wait. So people are joining one by one. I can see one Mr. Mahesh Sharma. I can see Nigamanand Roy, and other people will join slowly.
All right.
And we will put off our camera and also put off our voice. Sound once we start your actual presentation, online presentation. And your presentation is exact 25 minutes presentation. Just we checked in the morning.
Okay.
And it is about 25 minutes presentation.
Okay. That's the length of time you wanted, correct?
Yeah. Anything between 20 minutes to 40 minutes, 45 minutes is good enough, because this is almost 1 hour. What is the time at your place at present?
5:22 a.m.
Oh, it's early morning. Sorry, Kurt. Sorry. Because
that's. I had 5 kids. We're used to getting up early. So that's quite all right.
Okay. Simon has also joined. Simon Lovach from who has been in the IBAAS conference in Goa. Simon, how are you? Simon is from Switzerland, and he was also asking about you in the last conference.
Okay.
So he may ask you some questions, maybe. Yes, let us see. He is on sustainability. So more people are joining. Let us hope some more people will join, and then we will start.
Okay. And it's 4 o'clock Friday afternoon where you are, correct?
Yeah. We are almost, you say 12 hours difference from you?
10 and a half.
12 and a half. Yeah. Always half an hour is added. 12 and a half hours difference from you. Sorry, Kurt, it's so early morning for you, but it is mainly for Asian delegates and Asian people. So we have to keep the Friday evening. This is a much freer time for Indians and others, and not for North America or South America. Okay.
That's quite all right. It's not a problem.
Okay, good. So let us wait. Some more people joins, then we can start the things. So already eight people are here. 8 persons are here. Good. Mahesh Sharma, Simon Lovach. Okay.
Hello. Sorry. Hi.
Hi, Mahesh Sharma. Hi. From which company, Mahesh, you are?
From Aston Extrusions. We met at the Goa conference. Hi.
Goa conference. Hi. Yeah, now I remember.
Sorry, I was on a call. I got an urgent call, so I had to switch off my mic and my camera.
Please. Welcome, Mahesh. Welcome.
Thank you so much, sir. Thank you so much.
Yeah. So it may be interesting topic. Then you can directly connect with Kurt if you have any interest. So you are.
Good afternoon.
Good afternoon.
is the aluminum extrusion. Aluminum extrusion you have, no? Yeah.
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 We have 2 extrusion presses right now.
2 extrusion press here. Okay, Shivanshu Jhunjhunwala is also there. Okay. Okay, let us hope more people will join in this interactive meet. Okay, so it will start at 4 o'clock exactly. So we have to give time. So we have another 5 minutes to go.
Okay. I'm not sure what happened to slide 17, that it didn't get recorded. So
you can later on explain. Oh, welcome, Dr. Chatterjee. Welcome. Okay. Jagdish is also here, our regular participant. Shankar is also there. Shankar Narayan. Welcome, Shankar. Hi, Shankar. Hi, Shankar, our old friend. And then we will have more people will be joining. Okay. And Dr. Chatterjee, I will introduce. He has just, he was chief of R&D at Vedanta Aluminium. And now he is like independent person, and he may also ask you some questions and this thing. He is always interested in whole value chain of aluminum industry, start from bauxite to aluminum downstream.
Thank you very much, Dr. Nandi.
Yeah, Dr. Chatterjee. Okay. Simon is there, and then who else are there now? 5 others. No more people are joining. So please just wait for another 3 minutes, and then we'll start. It's 5 o'clock for Kurt. He is in early morning in Indianapolis.
that's right. I've done a lot of work in East Asia, so I'm used to having my days and nights flipped.
I'm good. I'm on my desktop without a mic. Okay, no problem, Simon. Simon has sent message. Okay. Already 14 persons are here. Some more people may be joining. Oh, Takuo Harato is there from Japan. Hello, Takuo.
Hi, hello.
How are you?
Fine, thank you. And you?
Oh, I'm fine, Takuo.
Yeah,
Fine.
it's very nice to meet you. Okay.
Thanks, Takuo.
Konnichiwa.
Konnichiwa.
Who speaks Japanese?
Good, maybe?
Not very much, but a little bit.
Okay. Okay, Belengan, Maria, Jagdish. Okay. So now we have more than 15 persons, and we have another 2 minutes to go to start our presentation, recorded presentation. And I will request Kurt to introduce himself exactly at 4 o'clock. I will just give 5 minutes to Kurt, and then we will start the recorded presentation. Just for your information, this is 24 minutes presentation, but very interesting. And he will be available for post lecture questions and answers. So it will be very interesting to have direct discussions with him on this technology or on this process. Okay, Satyanarayan Das has joined. Very good. Some of my friends from Guinea have also joined. Okay, welcome, ladies and gentlemen. Today we have with us Kurt Koehler from Indiana, USA, and he will be talking about this year's hydrogen production facility, what he has developed. And I will request Kurt to introduce himself for 5 minutes, and then we will start the recorded presentation, which was sent by Kurt. So Kurt, please, over to you.
Okay, Dr. Nandi, thank you very much. I appreciate everyone's attention for this webinar. As introduced, my name's Kurt Koehler. I am the founder and president of Hydrogen on Demand by AlGalCo. My background is not technical. I'm a serial entrepreneur. I've started 5 companies, three of them in the United States. 2 of them I sold to partners in Shenzhen, China. I have been working a lot in my youth in East Asia. I've been going to China since 1982, when Xiaoping opened up the country for people like me. So I went to China when Shenzhen, China was a fishing village of 10,000 people. Now it's a city of 9 million. So I was able to get on the ground floor of that opportunity. And I've started, my first company I started was in financial services when I lived in New York City and worked on the New York Stock Exchange. And then I started my own mutual fund, sold that one. And then I worked, I bought a little piece of General Electric and sold that to partners in Shenzhen, China after about 5 years. So I used to go back and forth every 90 days. I'd go to China, sometimes to Hangzhou, mainly Shenzhen. I go to China, then I'd come back to the US for my factory. Then my partners would come to the US to my factory, and then I'd go back there. So we did that for about 3 or 4 years because there was no real way that anyone had done business before in China, with the US anyway. So I sold 2 of my companies there. And then I was doing consulting work, and I stumbled upon a professor at Purdue University, which is just north of where I live, about 50 miles. And he told me that he could make hydrogen on demand from aluminum and water. So I told him that that's not possible, that for hydrogen production, you had to have a big high pressure tank. And he told me that he had discovered in a lab accident a way to depassivate aluminum and be able to make hydrogen. So this was in September of 2005. So we've been working at this for the last 19 years. So all we had at that point in time was a one-page phase diagram that just, you guys are all experts on this, so you know exactly what it looks like. So I worked with 2 of his PhD candidates up at Purdue University for 2 years in a little lab off to the side. And we were able to increase the amount of aluminum and decrease the amount of gallium. The gallium is what, as you know, depassivates the aluminum. So then we worked there for 2 years, filed for the patents issued. Then we started working with, we found that when you put gallium in there, the water has to be above 82 degrees Fahrenheit, or else the reaction slowed down. So I asked him what else would depassivate, what else has gallium in it. He said GalliumStan. So we tried GalliumStan and as the depassivating agent. So we got to the point where we could do 90% pure or a regular P1020 aluminum and 10% of the catalyst. So we've done tests that we could do better, more aluminum, because that's where all the energy is and all the expenses in the catalyst. But we figured that 90% was good enough for what we did. And then we worked with the military on 4 different projects. We powered generators on pure hydrogen. That was our proof of concept, I think 16, 17 years ago. There's a YouTube video out there somewhere. And we were able to operate a 1 kilowatt Honda generator on 100% of the hydrogen we made from this process. Then at that point, we had a number of interested parties that wanted to, they had green fleet initiatives, these cities and towns around here. Indianapolis is Indianapolis 500. So we're big in the automotive industry. This is state of Indiana has 5 manufacturing plants. Honda, Toyota, Ford, General Motors all have final assembly plants here in the state of Indiana. So in the Indianapolis 500, it's a car race. So this has been our background is in automotive. So we took the hydrogen we made from the process. We were able to do a 8-year beta test. So we made a hydrogen on tap system, hot, as we call it. And you put this in the back of a truck. You start the engine, water drips onto the alloy. The alloy generates hydrogen on demand. We feed it into the intake manifold as supplemental hydrogen. So we can run fuel cells. We did that for a Navy project. We can run internal combustion engines. We can do 100% hydrogen. We can do supplemental hydrogen. When you do that, the hydrogen is you increase your fuel mileage and reduce your emissions. So what's unique about our technology is the fact that we can make the hydrogen on demand. I don't have to have high pressure storage tanks, which is a huge advantage because hydrogen is, for being such a small, simple little molecule, has some really interesting characteristics. One of those is it's very aggressive. So if you are storing it, it has a tendency to leak. So we can make the hydrogen on demand. And the second part, the reason we're talking today, is that the aluminum oxide, it's not 4 nines, 2 nines pure alumina. It's not what you guys are used to. It's mainly about 90% aluminum oxide. The rest of it is the catalyst and the oxides of the catalyst. But we were able to test this at MIT. We tested this in AlCoa in Pittsburgh, Pennsylvania, about 300 miles from here. AlCoa Technical Center, and then Rusal, we work with them, and they tested in one of their facilities, and they were able to re-smelt our aluminum oxide back to the alloy. So I know your quest is to have as pure as aluminum oxide as possible. That's not what our aluminum oxide has all kinds of stuff in it, but it's still capable of being used as standard Hall cell and recycled back to the alloy. What this means is that we're able to recycle. We have a feedstock for hydrogen that is recyclable using standard aluminum industry techniques. So it reduces, when we do that, our cost is reduced by about 95% for the hydrogen. And I was just in Japan for a month because for over-the-road trucks, this is a solution for them. So it's you have a fossil fuel, use it once and it's done. We use our aluminum alloy, we're able to recycle it, and a number of times without losing any efficacy in the generation of the hydrogen. So it's an opportunity for the aluminum industry to get involved into fuels. So that's a big opportunity for us, and I think a big opportunity for the aluminum industry.
Thanks, Kurt. Thanks. Very nice, your introduction. Now I will request Priyanka of IBAAS office to start the presentation of Kurt. So please put off your sound and also camera. So now our actual presentation will start. Over to Priyanka.
Good morning, good afternoon, good day. I'd like to thank everyone who made this possible to be able to offer this technology at the webinar. I tried to get to the conference the other month, but we had visa issues, so we're unable to come there in person. But that's why I'm grateful for this opportunity to give you a little idea, 18 slides, so you know how much you have to sit through, to be able to get a feel for what we offer and what the opportunity is for the aluminum industry. As introduced, my name is Kurt Koehler. I'm the founder and president of Hydrogen on Tap by AlGalCo. So we've been around for 19 years. We are in the industry and the energy industry and I'll get a little more specific as we go. Our primary goal in energy is to somehow replace or supplement fossil fuels for several reasons. Number one, energy security. We're all aware of this. The movement of oil, drilling of oil, it's fraught with risk, especially in countries that are not blessed with huge oil deposits. The second thing, well, 1A really, are emissions. So we're trying to reduce the greenhouse gas emissions, oxide of nitrogen, other things that comes out of internal combustion engines, and of course, sustainability. We want to be able to not just use it once and then say goodbye to it. So what we are in the business of is producing hydrogen. And the reason why is it reduces the dependency on oil. It burns clean. You can use it in a fuel cell. You can also use it in an internal combustion engine. You can do partial hydrogen, supplemental hydrogen, all the way up to full hydrogen in internal combustion engines. So, and plus it has a benefit as that's the most abundant element in the universe. So the problem is, why not hydrogen? Why aren't we full-blown hydrogen right now? Three main reasons. It's expensive to extract. As you know, hydrogen is usually connected to something else, and it takes energy and effort to be able to break it apart. There's a carbon in there, you've got methane. If there's a oxygen, you've got water. So you have to be able to extract the hydrogen from the other elements it's with. It's difficult to transport because this usually involves high pressure, and it's very difficult to store. So for a basic molecule hydrogen, it has some really interesting characteristics. So the market for hydrogen is immense because so is the market for fossil fuels, for diesel and gasoline. So one of the main markets is transportation. Ocean-going ships are another big consumer, especially of diesel. And we're in the position right now where the last 10, 15 years, we've been more and more into energy storage. And the problem is, how are you going to store the electricity when that's generated by windmills, and especially windmills for us, for our technology? But how are you going to store that when you have times where you have peak production, but you don't have peak demand? So why AlGalCo? The reason why, two main reasons, is that we have found a way to depassivate aluminum. So when you add water, and this is any kind of water, it doesn't have to be ionized or deionized, well water, city water, any kind of water works. So when water comes in contact with our aluminum-based alloy, it generates hydrogen on demand. So it's a situation where we can address lots of issues with hydrogen because I don't have to store it in high pressure tanks where it's very aggressive and it finds a way out of any leak. We can make it on demand. And the second benefit of this, and it's most relevant to this group, is that it's renewable. So after we depassivate the aluminum, the oxygen in the water molecule combines the aluminum to become Al2O3, so aluminum oxide. So what we've done the last 19 years, we have focused on the material science part of the technology. Then we worked, we did 4 projects with the US military, 2 for the Army, 2 generators for the Army, a PEM fuel cell for a Navy project, and then also we worked with the Air Force on drones. So a number of years ago, they sequestered the budget in the United States. So we were contacted by several fleets, municipal fleets, that said, you know, we have a green fleet initiatives, and we need some kind of system that is going to clean up the air, that is renewable, that does not negatively impact the performance of the vehicle. There are usually around 6 to 8 requirements. So we took we built a prototype, a 600-pound prototype that we put an alloy, added water to it to generate hydrogen. So after, I don't even remember how many iterations, probably 20 iterations, we came up with a hydrogen on tap hot system. And what this does is this picture in the upper left-hand corner, that is a standard F-150 driven in Carmel, Indiana, which is a suburb coterminous with Indianapolis, Indiana. That is a city and a state in the middle of the country. We are about 200 miles south and east of Chicago, and we're about 500 miles pretty much due west from New York City. For those who haven't traveled to Indy 500, that's us. So we're known as an automotive state, so this was a natural fit for us. So the F-150 that the city of Carmel, which is a suburb coterminous with Indianapolis, you put this box. It's now a box. It used to take up about half the space, but what it does, it's inside this is to the far right. You have 3 canisters and a 4th one containing water. So the 3 canisters contain an alloy, 150 grams, a button. You start the vehicle, water drips onto the alloy, makes hydrogen. You feed the hydrogen as supplemental fuel directly into the intake manifold. So it looks easy now, but we went through a lot of different ways that didn't work. And we found that we can make this a very simple, very cheap system. So we have issued patents. We also have almost 2 decades of operational technology, proprietary, that is used in the actual operation of the vehicle. So what you see, what the result is when you start the engine, as soon as the engine started, the hydrogen flows, you get an 8 to 12% increase in your fuel mileage, and you get a 20% reduction in CO2 emissions because it's hydrogen. Now, it's not 100% hydrogen, it's supplemental hydrogen, which means that it does not negatively impact any of the systems on the vehicle. So that's one of the questions that the drivers always ask was, what happens if I run out of hydrogen? Nothing. You just don't get the benefits of using hydrogen, but there's no negative impact on it. So this is a list. There have been 40 to 45 other organizations and researchers and companies that have done the same thing that we did. They put supplemental hydrogen into internal combustion engine, and they wanted to see how that impacted the performance and the emissions. So you can't really see, but the first 2 are standard industry for performance, and the other 5 are particulate matter. Let's see, I think that's NOx, carbon monoxide, carbon dioxide. So you can see all the different teams, what percentage of hydrogen they put in, what load, and if it's all green, that's what you want. So we are not the only ones that have done this. We're just the ones that have done it most recently. And we did it with our hydrogen that is from a renewable feedstock, the aluminum oxide. So what we are doing now is we are scaling because we need high volume aluminum oxide. That's our business model, is to be able to engage the aluminum industry to recycle, to resmelt the aluminum oxide generated by our process. So to do that, we are now scaling to the 15-liter diesel engines. Fortunately for us, Cummins Diesel, which is one of the largest manufacturers of diesel engines in the world, they have 15-liter diesels. Those are kind of their standard size. So we've tested with them, with Cummins, down in Columbus, Indiana, not too far from us. So what we did is we took one of their test cells. This is a standard 15-liter diesel, Cummins diesel. And then we added, you can see we had hydrogen at different levels, different flow rates. And then we shut off the hydrogen. And you can see that you don't get the emissions increase, and the fuel mileage decreases. Then we turned it back on, and it spiked up. And we turned it back off, it went back down again. So that sawtooth pattern, that was a screenshot of when we tested the standard 15 liters. So what that means is when we bench test our system, then we're able to get on an over-the-road diesel truck about a 7% increase in fuel mileage and a 30% reduction in NOx. And NOx and diesel engines has always been an issue. So it's carbon monoxide, carbon dioxide, particulate matter, all that. But the oxides and nitrogen have been the main pollutant that come from diesel engines. And there's really no other way to address this besides going into 100% fuel cells. Then you have high pressure storage on board. and all that. This is our solution for supplemental hydrogen for over-the-road trucks. We know it works in F-150s, standard 5.4 liter V8s that we spend a decade in Carmel and Fishers, Indiana, another municipality, and did our testing there. We know that project's done, it works, it's fine. So now we're scaling it to the 15-liter market. So most interest to this group is this slide. This is slide number 11. This is what happens when you recycle the aluminum oxide in a standard hull cell and during the standard procedure that you guys use to make aluminum. You know this better than anyone in the world. So what we found is you can take the aluminum alloy. We have a vendor that makes that. Then you make your hydrogen on demand. Then it becomes aluminum oxide. And then it goes through the same process you do every day. Calcination, electrolysis, then you pour it into an ingot, and then it goes back to the over-the-road trucks. So what you have is a sustainable feedstock for hydrogen using aluminum industry infrastructure, which we already have. So what this represents, the aluminum industry, is an opportunity to be able to get into the transportation fuels market globally. This is a multi-trillion-dollar market. I know just in the U.S. we spend probably $700 or $800 billion a year just the U.S., not Canada or Mexico, not Asia, Europe. Just in the U.S. we spend $700 to $800 billion for gasoline and diesel fuel. So this is an opportunity for the aluminum industry, which is low-cost leader is in India, a chance to get into this market. So the opportunity it represents is massive. Now, we have tested this before we got too excited about it. We tested it with MIT. They tested independently. Then we tested with AlCoa and Pittsburgh, ATC, the Aluminum AlCoa Technical Center, with small hull cells. And then we tested it with a group with Rusal in Europe, in one of their facilities. They took a substantial quantity of our aluminum oxide. They smelted it. They came back around. They put the water on it. They got the same yields, and they tested it numerous times. These are their numbers. So, and you'll also notice that the emissions reductions is substantial when you are recycling aluminum oxide versus making virgin P1020 for the first time. So this to me is the most important slide for your group to be able to give you an idea of what kind of opportunity this technology represents. So cost reduction, we've been through the numbers. This shows 128,000 trucks over the road, 15-liter trucks. That's driven. They're allowed to drive 600 miles a day, 5 days a week. They drive about 150,000 miles a year for an over-the-road trucker. And this is how many trucks it takes to generate 1 million tons of gray powder, which is 3.2% of the entire aluminum market. Now, what we have found is that 5,000 over-the-road trucks outfitted with a hot system to provide supplemental hydrogen and get the fuel mileage increase and the NOx reduction is only about 5,000 trucks need to be outfitted with that system. And what that will generate for the aluminum industry is we'll fill 100 hull cells. So 100 hull cells on a pot line will be able to generate it. And that's 24/7 with sufficient inventory, continuous flow, to be able to engage 100 of your pot line, 100 hull cells in your pot line. So that's just with 5,000 trucks. And then the 128,000, that will get you up to 1 million tons. So that's a substantial quantity. And we think it's worth your time. That's why we wanted to sit down and kind of discuss this with you. So right now we are scaling up the hydrogen on tap, the hot system, for marine diesel engines and for energy storage. So the 5,000 trucks and the 100 hull cells, that is just for 5,000 trucks only, not more trucks than that. It doesn't include the marine diesel engines. It doesn't include energy storage. So the marine diesel engines, you have ships plying across the ocean back and forth. They're burning number 2 diesel fuel, bunker diesel fuel. And then once they get into port, New York, Newport Beach, when they get into port, all of a sudden they have to meet clean air standards. So they're not sure what the best way to do it. So what we propose to do in that market is just provide supplemental hydrogen. It cleans up the exhaust, increases your performance of your engine. So that's not another gigantic market. I don't have the numbers for that, but I know it's substantial. And the second expansion for us is the energy storage. So we have all these windmill farms that, especially in our home state, that they're only using a small percentage of the power generated, because the best wind is usually between midnight and 4 in the morning, but that's when the least demand is. So 82% of the energy made in a windmill, in where we are anyway, I'm not sure about India or China, other parts of the world, but I know in the US and Japan, I've talked to them as well, they're only using 18 to 20% capacity. So what we propose is use the electricity from the windmills in off-peak times to a smelter. We can use an existing pot line. You don't have to build anything new, and be able to store the energy from the windmill in the form of our aluminum alloy. So if you ever have a zero wind day, which is always the worst case, is you just simply add any kind of water to the alloy, make hydrogen, and run a generator on site. That way your windmills always have some electricity flowing from it no matter what the weather is. So it gives you a baseline, which is the problem we have with energy storage, is the renewables are intermittent. This is a way to take some of that intermittency out of it. So this is, the utilities companies are very interested in this because it saves them a lot of money, because they have to build a facility that is able to always provide baseline power no matter what. So they don't have to build, or they can build more baseline and not as much from the renewable if they use our energy storage method, which is another market for the aluminum industry, because every time you use it, you're gonna have aluminum oxide, need to recycle it. So the value proposition for our technology is that it reduces demand for gasoline and diesel, reduces CO2, reduces NOx. You don't have to build any type of recycling or infrastructure. It already exists. In the US, we have 26 smelters, only 5 are active. The rest are still there. They don't tear them down because they're huge and very capital intensive. But we can use those hull cells, those smelters, for recycling our alloy without having to build anything new. So for example, I know Novalis is very active in North America. Novalis is in Atlanta, Georgia. They don't have a smelting presence in the US, but there is a plant called Century Aluminum, which is within less than 150 miles from us, that's for the last 3 years has been mothballed. And that plant's a regular smelting plant. So what we want to do is have Novalis, and we know AlGalCo is the owner, is be able to use that in Kentucky, to be able to, the state next to Indiana, to be able to use that to recycle our spent alloy. So that way Novalis would have a way to get into the smelting business, get into the transportation fuels and the energy storage and the marine diesel market with a facility that's already there, not generating any revenue, and it hasn't for the last 3 years. So that's kind of what we're thinking about. And then also another value proposition is there's no modification of the vehicle engine. This was a huge, I'd like to say because we're smart, but it's not, it's because we're lucky, is that the sensors on the engine know there's something burning there besides regular fuel. And so therefore it leans it out, and that's why you get fuel savings when you run supplemental hydrogen. There's no demand for the system. The hot system runs at about 5 PSI. It's completely renewable because it's from the aluminum oxide. We've recycled it. Rusol's recycled it. AlGalCo has recycled it. We know it works. And right now on the cost side, in Japan and the EU, because the price of diesel is so high, when you recycle the alloy, our hydrogen is actually cheaper in those 2 parts of the world than the diesel that it replaces. So that's, everyone talks about, well, a green premium and all that. Right now, when we recycle, we are cheaper than diesel fuel in Europe and Japan. So we're working on that for the US. We have lots of cost reduction. That's in our business plan. But it's a situation where we're not asking for a big premium. We think we can go head to head with diesel in parts of the world and have our hydrogen replace it. And our hydrogen's from aluminum that's recycled by the aluminum industry in India. So one question often asked is it scalable? Our proof of concept 17 years ago was a 1 kilowatt portable generator. We ran it 100% on hydrogen. That's for emergencies. You have a tornado or tsunami or hurricane, then someone's on a feeding pump or oxygen mask. They die without having a generator. And they don't want to keep cans of gasoline. That's fine. Just keep buttons of alloy. Just keep it dry, and it's regular P10 aluminum, most of it, and then our magic sauce. We also ran a 1.3 kilowatt PEM fuel cell. We did the 5.4 liter. That's a regular gasoline engine. F-150 is the most popular selling vehicles in the US the last, I think, 35 or 40 years. And we're scaling now for the 15 liter diesel trucks. So right now, competition-wise, the number one way, I think like 97% of the world's hydrogen is made from reformulated natural gas. So you take your methane and you heat it up and you break apart the molecule and you either outgas the carbon dioxide, or you just put it, maybe carbon sequestration, but there's a lot of problems with that. That's how most of the hydrogen is made. Our feedstock is recyclable. You can store it, just keep it dry. It stays dry forever. Don't have to put it under pressure. Just make sure it doesn't get wet. We can fuel cells, and then the infrastructure for recycling already exists. Everything is already there. That saves us lots of money because I don't have to go around building aluminum smelting plants. We can use the plants that are already here. India is their cost competitive leader. That the better the price is, that means the cheaper the price of hydrogen is, which means that it makes implementation that much faster. Because you can see those trucks go through a lot of diesel, and they'll go through a lot of aluminum oxide. And the more they go through, then the more money everybody makes. Slide 17 is the last slide. And in it, we detail the advantages of the hydrogen on demand by AlGalCo technology to fleet service providers. Those are people who take care, who maintain and install systems for over-the-road trucks. Commercial fleets, the advantages are the increase in fuel mileage, the reduction in emissions. That gives them a competitive advantage in the marketplace. They can move goods and services at lower emissions, and it helps their profitability. The OEMs, it's the same situation. They're under mandates mainly by the EPA to reduce emissions. And most relevant for this group, the aluminum industry. This technology with the aluminum oxide recycling allows the aluminum industry to gain access to a very, very large market. And that market is for transportation fuels. It's a multi-trillion-dollar market. It's global, and it scales. It's a commodity type, just like aluminum is. And it allows the aluminum industry to access this market plus the two new applications. So it can be a substantial increase and incremental new business for the aluminum industry. Also, the windmill farms as energy storage, and it's also advantageous for the utilities because they will be able to have some electricity from all their windmills, so they don't have to build as big a base load capacity, which saves them a lot of money. So I appreciate your time. That's us, and I look forward to your questions.
Thanks, Kurt. No. So very interesting presentation. Very interesting presentation. Now Kurt is here, and this is open for now discussion. And you are welcome to ask directly to Kurt. He will answer it online, and he will be available, and it's open for discussion. Please start.
Thank you. Yeah, I will like to go ahead.
Dr. Chatterjee. Dr. Chatterjee, please introduce yourself. Yeah.
This is Dr. Amit Chatterjee, ex-Chief R&D Officer of Vedanta Aluminium. And very good presentation. And the subject you have chosen is something which is very important from the, green energy sourcing. And I would like to ask you a couple of questions here. When you compare this technology as compared to the green hydrogen from the electrolysis of water, which is one of the ways every government is looking at producing the green hydrogen for mass scale application. Where exactly it stands in terms of the capex and the operational cost? That is number one. It appeared to me that the alloys for the reaction with the water that you are using is a proprietary kind of alloy which your company has developed. Otherwise, the aluminum which you get normally would be probably subjected to the oxidation, and the thin layer would be actually resisting the reaction of the aluminum metal with the water. So my question is, if it is a special type of alloy, is this technology going to be applicable for recycling of aluminum, which is a subject which is spoken in number of platform, that this could be a very good technology for generating green hydrogen from the recycled aluminum? So that is one question. And the last one is that the aluminum hydroxide which is being generated in this reaction, does it also contain any contaminant which might not be suitable for the electrolysis of
Very good.
aluminum pure metal production in the electrolytic smelter?
The second question is yes, the gallium that depassivates this along with the other two main elements, you cannot use it on a regular production line, because if the gallium gets into your regular production aluminum, when you fill a beverage can with water, it's going to react. So you have to have a segregated production line to be able to resmelt the AlGalCo aluminum oxide. That's when we went down to Alcoa. There's a big plant here in the U.S. close to me, and they would not let us in with the gallium because it will contaminate their pot line. So you do have to have a separate pot line to be able to keep our gallium. You need to keep that away from a normal production pot line. So yes, that's one of the things which in India might be a problem because you guys are fully utilized. In the US, we have most of the aluminum smelting has migrated to China and India. So we have all these vacant pot lines. It's not a problem for them. But yeah, you have to keep our aluminum oxide, our byproduct, you have to keep it away from a normal production line.
Okay.
That's a very good question.
Okay. And how does it compare in terms of the capex and opex with the green hydrogen from the electrolysis of water, which is one of the ways every company is looking at today?
Okay. Water electrolysis, the problem is that you get Brown's gas instead of pure H2, so you cannot use it in a fuel cell. If you use Brown's gas in a fuel cell, it will degrade the operational capabilities of the fuel cell. So you have to use pure H2, and water electrolysis does not generate pure H2, it generates Brown's gas. We found that out when we tested with the US Navy. They had a project that you had to recharge lithium-ion batteries in a submerged submarine. So you had to have pure H2 run it, and they found that the Brown's gas doesn't work. It's not efficient in a fuel cell. So that's the advantage of our hydrogen is it's pure H2, not Brown's gas from water electrolysis.
Okay. Is it possible to define the purity level of this hydrogen as compared to the other one? Do you remember any number?
I don't remember the numbers. We did test that. We did all of our testing up at Purdue University. So they have a whole nanotechnology center. So we came in, we would take the night shift and we'd be able to test all the alloy. So we know the gallium, we know that it goes into the grain boundaries, and we analyzed the purity of it, but I can't remember off the top of my head what the number was of the purity of the hydrogen it produces.
Okay. Okay.
So I'll have to go through my records to see what that is, but that's another good question.
Just one last question. For 1 kilowatt hour of the fuel cell, if somebody wants to build using the hydrogen from here, hydrogen fuel cell, what will be the kind of capex involved in this case?
The capacity you would need for a fuel cell, Well, the way we did it is we'd go on flow rates.
Okay.
So what we did is for like the internal combustion engines and for the fuel cells, we know how much water and how much alloy, how fast to generate the flow rate that we need.
Right.
For example, the flow rate on an internal combustion engine, 5.4 liters is one number. For a 15-liter engine, it's a lot higher number. So we did the flow rate. What we did is when we tested these on the bench, is we would set up a tank, a torpedo tank of hydrogen, and we feed it at different levels, and then we measure all the different factors involved. So we found the ideal flow rate for hydrogen, and we know what that is by our 8-year, 10-year beta test in Carmel, is how much water. We know what the yield is, all those numbers we have. So we did it all on flow rates. So we know what the flow rate is for the different engines and for the fuel cell.
Thank you very much. Thank you very much.
Thank you.
Yeah.
And request Simon, please go ahead with your question. Simon Lobach. Hello. Hello, Simon. Okay.
The hand is raised.
Hand is raised. Yes. Please. Simon.
Sir, he has asked this question in the chat box.
Chat box, I will pass it on after this meeting. I will pass it on to Kurt, and then Kurt may reply later on. So now it's open for anybody to ask question, please. Anybody? So just in between, I would like to see the alumina analysis which is produced in between, and whether this alumina can be used other than electrolysis. We can use it in refractory abrasive industry also, because this is not necessary to use again to make aluminum alloy. So Kurt, can you show us this alumina analysis result which is produced in between?
Yes, we analyzed it. I can send you those. I can send you the analysis of it. The vast majority is aluminum oxide, plus you have the 3 catalysts involved, and then their oxides as well. Yes, I can send that to you. That's fine.
May I make a comment, Dr. Nandi?
Yes, yes.
The process, what I understood, what I understood from Kurt, they are using an alloy, and therefore addition of the alkali, etc., is not probably required. And it is the alkali level in the alumina which actually is a deterrent for different kind of application, high value application, even for electrosmelting to produce aluminium metal. But they are using an alloy. They are not adding any, alkali to bring the pH increased level, so that the oxidation of aluminium metal does not happen, which is a deterrent for further reaction of water and aluminium metal. So therefore, this process has taken care of the contaminants which might otherwise go into the alumina as well.
Okay, so is there no other use of this aluminum other than going again for electrolysis?
No, there are good number of uses. The moment you have less soda, less iron, less calcium, you have large number of uses.
Yes, refractory, abrasive, ceramics, a lot of...
no, not only ceramics is probably at the middle level or lower level. You have 3N purity aluminium oxide. You can produce 4N purity aluminium oxide, the mobile phone, etc., the display unit, the Gorilla Glass. So these are very high value application of alumina.
Okay.
And even activated alumina is one area which is a very big subject, water purification.
Exactly.
Alumina. So there are a good number of application. Calcined alumina for refractory and other application, and all the high value application. Even aluminium hydroxide for the electrical cable. That's a very, very good, filling agent, along with the polymer, the PVC and the HDPE for the cable application.
Very good. So, Kurt, we'll wait for your alumina analysis. Please send it to us. And now Simon is there online. Simon, please ask your question.
Yeah, sorry, I was on a desktop without a mic, so I switched to my phone, so now I can speak to you.
Okay, Simon.
So my question is regarding one very basic assumption in your presentation, which is that the alumina will be turned into aluminium again using a green energy. Now, as we know, the green energy is currently only able to produce half of the world's aluminium, right? The rest is made with fossil fuels. And this will be the case because we do not have the green energy requirements yet to increase this share. The infrastructure is not there. So you use this intermittency argument, but is it really the case that smelters can adapt so quickly to changes in green energy supply? And if they can, why don't they do it yet for other purposes? So basically what I'm saying is there is, of course, a risk that you will end up relying on fossil fuels to produce the aluminium that you will then use. And then my question becomes, the energy impact of doing this, how does it compare to the energy impact of producing conventional hydrogen? So if you would, in the end up using fossil fuels for this, does it compare favorably or no to other ways of producing hydrogen?
Where we are, we use natural gas. So for the smelting plant we have in Alcoa in Evansville, Indiana, it was a coal-fired plant, and then they repurposed it to natural gas. Because with all the fracking, a lot of the fracking is in this part of the country, this part of the world. So we use natural gas right now to be able to power the smelters down in Alcoa. So, and it's just it's the same thing, you guys, 14.4 kilowatt hours to give you 1 kilogram of aluminum. There's nothing different about that. So it doesn't really matter in the production if you use fossil fuels or renewable energy. It's the same electricity. It's the same for us. What we have proposed is in the northwest part of the state, of our state, we have 1,200 windmills, and those windmills are only using 18% of their capacity. So the rest of it literally goes to ground. So our proposal to the state was to take the windmill energy, run it down to Evansville, Indiana, and then that way you have a completely green renewable cycle. So we would prefer to do it that way. If we have to use fossil fuels, we use fossil fuels. But either way works with us because all we need is the electricity.
Yes.
To power which is a problem all over the world for the aluminum industry, right? Because it's very energy intensive. So we're agnostic on where the source of electricity comes from. We just happen to be in a place where they spent $3 billion building 1,200 windmills that we're only using a little bit of it. I mean, all that electricity goes to Chicago, not in Indiana. So we talked to the state of Indiana about directing that down to Evansville, and that way we have the whole thing green and renewable. So that's what we'd like to do. If we have to use natural gas, we'll use natural gas, but we prefer to use the renewables. But yeah, it's very, as you know, and it's very energy intensive to be able to smelt aluminum oxide back to our aluminum alloy again.
Yeah, but now you're making a comparison between aluminium for other uses and aluminium used for your purposes, right? That's fine, but of course, if this becomes a solution at scale, that will create an increased demand for aluminium in the market. So and to me, it seems intuitively that to use aluminium to produce hydrogen is a bit of a detour that actually creates a lot of additional energy demand that would not be there if you would use another way of producing hydrogen. I get what you say about other ways of producing hydrogen and the risks associated with it. But I just wonder if this would end up being with fossil fuels, how would it compare to other forms of hydrogen production? So not other forms of aluminium production, but other forms of hydrogen production.
The other two main forms, as you know, are you take the natural gas, you heat it up to 800 degrees, and to reformulate it, and you still get a CO2 outgassing when you do that. So that's an issue. The another issue is when you do the water electrolysis, you're going to outgas CO2. So what they've been doing is talking about carbon sequestration and putting that thousands of feet under the ground. Well, the problem in the US anyway, I don't know about the rest of the world, but here in the US, when you put high pressure gas under someone's land, that is they're pushing back against that. So that's a real problem because we have the state of Indiana is the #1 producer in the US of steel. So they're trying to find ways to green the steel making industry. And reforming natural gas was one option and water electrolysis was the other. And both of those they found is there's lots of difficulties, lots of additional energy to be able to heat up that water electrolysis, or I'm sorry, to be able to heat up the reforming natural gas. That's a lot, an additional, I can't quantify it, but it's a very energy intensive process. And if you use water electrolysis, then they were going to use solar panels for water electrolysis. Well, the problem was when you do that is the storage, it becomes an issue on the storage. And what do you do when the CO2 that outgasses? So yeah, there's no ideal solution. We just think that we like our solution because if you're an over-the-road trucker and you're going to put another way to lower your emissions, you're going to have to go to a fuel cell. And we spoke at the Detroit conference, and what we found is that you're looking at 10,000 PSI, 700 bar storage for hydrogen on board an 80,000 pound over-the-road truck. And that's all kinds of problems, safety issues. I mean, how do you refuel in the middle of most of our truckers refuel in rural areas because it's hard to get a big truck downtown. So they put them out, they put the gas stations. Well, how are you going to get enough energy to be able to cram enough hydrogen on board a vehicle at that kind of high pressure levels? So the refueling is a major Achilles heel for other alternatives in the transportation. And the diesel truck market in the US is immense. I know in Europe and in East Asia especially, it's also an issue, but we've got 3 million over-the-road trucks just in the US alone. And you're looking at how are you going to address the NOx issues? You know, that's a real big one. And going to fuel cells, I mean, our hydrogen works for fuel cells, pure H2. That's fine with us, but we think it's more practical to start out with supplemental hydrogen, get the benefits, get the market used to hydrogen, and be able to scale up. That's where the aluminum industry is critical for us because you guys want high volume. That's the first time I talked to Alcoa. They said, how many tens of thousands of tons are you going to do every month with us? So I said, well, can we start with 5 trucks? And they said, no, we got to have, we have a pot line. We have to be able to do high volume commodity style. That's why we decided to go to over the road trucks to be able to engage the aluminum industry. But there's still technical issues, and the world needs more energy. But for just looking from our perspective only, we hope it comes from renewables. But if it comes from natural gas, it comes from natural gas. The electricity to be able to resmelt this.
Thank you very much. It's very, very insightful. Maybe it would be interesting, but maybe that's because I come from a university setting, not from a company. But it would be interesting to see this comparison that you just made between pros and cons of hydrogen in your system versus hydrogen in another system, and quantify it under a fossil fuel scenario, so that even with fossil fuels there may be benefits, right? Because to say it's renewable because we use renewable energy, that may be too optimistic. And if your solution is still, if that is not possible, still a better solution, that may be actually interesting to point out.
I guess the way we looked at it as entrepreneurs was put it on the road and road test it and see what happens. So we still work with Purdue University, and they always look at it from an academic, do an analysis of the two ways. But no, that's a very good point. I will come up with something on that one.
Good. So more questions. I'm seeing Dr. Amit Gupta, a smelter specialist from AlGalCo. So Dr. Gupta, do you have any question?
No, I don't have. Thanks. Thank you for excellent presentation.
Okay. So anybody else would like to ask? Mr. Ashish Gupta is there. Then many people are here. So any more question? Madi is here. George Benevolgi, how are you? Alumina expert. Okay. Jagdish is here. Khalil Khaji is here. Smelter expert. So you are welcome to ask question, please.
How much does it weigh?
Jagdish.
Yeah.
Please
How much
repeat.
does it? What is the weight of the system? Because it is going to be carried in a truck.
The hot system,
Yeah.
when we started, the prototype was inch thick, 300 series stainless steel. It weighed about 400 pounds. The new hot system weighs about 60 pounds.
30 kg.
So 25 kilos.
So how much water is required?
We have on the system that we have now on the mid-sized trucks, you have 6 liters of water. For an over-the-road truck, and that will give you supplemental hydrogen for about 250 miles, because that's how far these guys will drive their truck before they come back in for fuel. For an over-the-road truck, for 24 hours of operation, at the ideal flow rates, you're looking at about 48 gallons of water.
Right. Okay. And how frequently it has to be recycled? How long does the aluminum last before it has to get recycled?
When we go through the refuel, we have put enough alloy on there for 24 hours of operation on an over-the-road truck, or about 1 week on a mid-sized truck, because they're more of a stop and go kind of situation. So there's no time limit. As soon as it reacts, then we can recycle it. So you don't lose any efficacy. I mean, it's just aluminum oxide with 3 catalysts in it.
Okay, right. Thank you.
Okay, very good presentation, good questions and answers, and all this presentation will be available on IBAAS website, and whoever is interested, they can directly contact Kurt. Please just indicate, and we will provide the email address and coordinates of Kurt. So please be in direct touch with Kurt for further queries and questions, and presentation will be available on the IBAAS website. Thank you very much.
Thank you
for
very much.
joining. And
Thank
if
you.
you
Appreciate
still have,
it, Nadi.
yeah, please. And if anybody still have questions, Kurt is available. Otherwise, you can discuss on emails or, Ashish Gupta, please ask question. Please, Ashish Gupta or Omar. Simon, okay, thanks. Thanks to everybody, and we will join in December also, last week of December on Friday, and most probably Dr. Chatterjee will be delivering some presentation, and we will give a wide publicity. IBAAS will give wide publicity. So we'll welcome in the next lecture series. It will be monthly lecture series. Every last Friday of every month, we organize this thing. Thank you very much.
Thank you very much, Dr. Nandi.
Thank you.
Thank you.
Thanks, everybody.
Thank you.
Taco. Bye.